Hey Algebra, this is your first practice test. Let's jump into it. Solve the equation or inequality. Use properties of equality and show your work. So do your best to show your work. I know some of these you're going to go, I don't need to show my work, but give it a shot. I'm going to move through this rather quickly as this is, the test. Kind of hoping that you know roughly what you're doing. Distribute the -2. I'm going to go ahead and subtract that 2 also. Going to subtract 18 and divide by -2. Add 7. Divide by -2. Multiply or distribute -4. I'm going to do two things at once here. I'm going to subtract 2x. I'm going to subtract 12. I'm going to add 5. I'm going to multiply by 4. I'm going to actually cross-multiply, and you might think, well, that's strange. How? I didn't know we were able to cross-multiply. With a fraction equals a fraction, actually, cross-multiplying is just, hang on, let me back up. A fraction equaling a fraction, you can cross-multiply. In fact, here, I'll keep the colors consistent. 2 times 15 is 30. 5 times 8 is 40. And then the x is actually going to stay with the 30, because if I were to rewrite this fraction, it would look like this. And if you're out there going, you know what, I would have just divided by 2/5. Okay, cool. Then that means you would have multiplied by 5/2. And guess what? You still get 40 30ths, which is what we're about to get here. When I divide by 30, you get 40/30, which is 4/3, or 1.3 repeating if you want. Subtract 5x, subtract 4. Distribute 3, subtract 3x, subtract 15. Divide by 3, x equals 0. Subtract 6. Multiply by 5. Distribute the 4. Distribute the 2. Subtract 2x. Subtract 8. Multiply both sides by 2. Subtract 2x, subtract 10. Add 8. Multiply by 4. Solve and graph each inequality. I'm going to add 6 first. So there's my first answer, and here comes the graph. It's going to be an open dot on 9 and everything greater than x. I'm going to multiply both sides by -5, which flips my inequality. So there's my first answer, and here comes the graph. Closed dot on 15. And x is all of the numbers that are bigger than -15. Subtract 4x, add 29, divide by 4, and here comes my graph. Open dot, x is all of the numbers that are greater than 8. You can split this up into 2 separate inequalities. I'm going to keep it as one and then just make sure I deal with all of the sides. And then this is probably something that almost tripped me up, so make sure and keep your symbols the same. Divide by 2, divide by 2, divide by 2, and we get 1 is less than x, which is less than or equal to 7. So there's that. Here comes the graph. Open, closed, shade in the middle. 3x, subtract the 6, divide by 3. 2x, I'm going to add the 6 to get 2. So here are my answers there. If you want to write the word or, go for it. 0 in the middle. We're going to have the blue is an open dot here and everything less than that. And this is going to be a filled in dot, everything greater than that. I have my absolute value already by itself, so I have my positive version, I have my negative version. Subtract 7 to get 2, divide by 2 to get 2. Don't forget, I didn't say it out loud, but on your negative version, flip the inequality, right? And then subtract 7, divide by 2. So these are your answers. Here comes the graph. Open dot, x is all the numbers that are bigger than 2. And open dot, all the things that are less than -8. Absolute value is by itself, so here's my positive version. Here's my negative version. Flip the inequality, right? -5, -3. And that's just because I want to just leave my variable on the left. So now I've multiplied both sides by -1 to get y is less than 3. Similar thing's going to happen here. Subtract 5, get -7. Y is now greater than +7. So there's one, there's the other. Here comes the graph. The yellow one is going to happen at 3. The red one's going to happen at 7. There's 0 for fun. Open dot, all things less than 3. Open dot, all things greater than 7. I'm going to add 3 first. I'm going to multiply by -5. There's my answer. K is less than or equal to -65. And it's going to be a filled in dot. And all of the numbers less than that. Solve each equation. Absolute value is already by itself, so here is my positive version. Here's my negative version. Add 4, divide by 2. Add 4, divide by 2. And they didn't ask us to graph here, so I'm not gonna. Solve for y. Solve for y. So I'm going to distribute the 5 just because it doesn't really benefit me to get rid of the 5 right away. I'm going to subtract 10a. And then I'm going to divide by 5. This is one possible way of seeing the answer. Another possible way is like this. Sorry, 5. Either one, it makes it happy. 23, you'll notice that on your copy, this says solve for x, so that's my bad. But you wouldn't have known what to solve for anyway. They both have factors of x, so I'm going to factor out x. And then I'm going to divide the entire thing by 5y minus 2, and that cancels this out, and I'm left with x equals 7 over 5y minus 2. Kind of ugly looking answer, but that's the answer. Solve for y, there it is. Subtract 3x. Divide by 5. Determine if each of the following has no solution, exactly one solution, or infinitely many solutions. So let's see, distribute the 3, distribute the 2. Over here I can combine this to be 4x plus 3, and this is 4x plus 6. It's right here that I can tell you it's no solution. And I know that because there's no number possible that when you multiply it by 4 and then add it by 3 that would ever equal multiplying the same number by 4 and then adding 6 to it. But if you don't see that, that's okay. Just keep going. So what if you were to subtract 3 next? Again, you can see right here, that's not going to work. But if you were to keep going, say you subtracted 4x from both sides, 0 definitely doesn't equal 3. So this is the, hey, we've definitely reached the it's not going to happen point. Let's see, 5x plus 2, distribute the negative 2, so I get negative 2x plus 2 equals 3x plus 4. This is a like term, so is that, so 2 plus 2 is 4. This right side doesn't change at all. And on the left side, 5x and negative 2x is 3x. And then I just forgot to write my plus sign. Check it out right here. I know that it's all real numbers or infinitely many solutions because the left side is literally equal to the right side. But again, if you don't recognize it, why don't you subtract 4? And then you're going to get 3x equals 3x. Do you see it now? If you don't see it, then okay, subtract 3x, I guess, or divide by 3. Let's pretend you divided by 3. You would get x equals x. I mean, yep, that's pretty obvious. And if you were to subtract x, you get 0 equals 0. So no matter what, we have infinitely many solutions. What would it look like if it was exactly one solution? Like that. Problem solving, document your thinking. 2 shops each charge a rental fee. Each shop charges a rental fee plus an hourly fee. So rental, hourly, to rent a canoe. How many hours must a canoe be rented for the total cost at both shops to be the same? To be the same is code, not really code, it's English for equal to each other. So if you are unfamiliar with how buying things works, I know you're not. If you were to go to shop A, to rent a canoe, you have to pay $2. And then you're going to have it for probably more than an hour. So how many hours are you going to have it for? I don't know. But this is how much it would cost for A. All right. And then here's shop B. Shop B is going to also have a rental fee and an hourly fee. So B is going to equal $8 just to rent a canoe. But then its hourly fee is a little less. It's only $4. So now we want to know, okay, what would it take for them to equal each other? Well, here's how you do that. You take the purple one, you take A, and you set it equal to B, and then you solve for H. So I'm going to subtract 4H to get H, subtract 2 to get 6. Boom. It takes 6 hours for that to even out, for them to be the same. Now, you could have potentially written out a lot of these scenarios. You could have been like, okay, here's A. You know, it costs them $2 plus 5 for 1 hour, $2 plus $10 for 2 hours, $2 plus $15 for 3 hours. I mean, you could have done that, but this is why, this is what we're looking for, not so much this, okay? So, in fact, I'm going to say, go away. I don't want to see you. But just know, that technically would have worked. Write an equation and solve for the perimeter of the given triangle. I changed it to solve for x of the given triangle because, I mean, there's the perimeter, right? Anyway, so perimeter is just, you start and you take that side and you're going to add it to this side and you're going to add it to that side. So it's x plus 1, that's that one. It's plus x plus 1, that's the blue one, plus x, that's the green one, and that's going to equal 38 because that's what we were told, okay? Now we just solve this. This is 3x plus 2 equals 38. Subtract 2, and it's 12. X is 12. Write an inequality and solve to represent this situation. Emily has $50 to spend on materials for a costume. So I don't know about you, but when I have $50, that is the maximum I can spend, okay? I can spend, less than that, but I can't spend more than 50 when that's all I've got, right? She finds the perfect fabric that will cost $5 a yard. So $5 per yard. And then she has a $15 off coupon, so minus 15 bucks. This is your inequality, okay? And if you're a little confused on why, this is how much she's buying, and once she's found how many yards she wants, like let's say she buys 10 yards, that's 50 bucks. And then she subtracts 15 because she has a coupon. Is that less than 50? Then cool, she can buy 10, right? And the reason I did that is just kind of to walk it out so you can kind of go, oh, I understand that I have set it up correctly. Divide both sides by 5. She can buy 13 yards or less. Solve. The sum of 4 consecutive integers is 90. So is 90 looks like this. In English is right here, and math is right here, okay? So 4 consecutive integers are like 1, 2, 3, 4. So if we were to represent this in algebra, that would be like x, and then x plus 1, because, right, this would be 1, this is 2. I'm kind of reteaching this in the event that you don't remember it, right? This is 4. So, and if you're, oh, actually, I messed that up a little bit. That should have been x plus 3. Because if we were to take this 1 and plug it in here, we get 1. We take the 1 and plug it in here, we get 2, etc., etc. So let's kind of clean this up real quick and just throw some other mathy symbols in there like this. That plus that plus that equals 90, okay? So x plus x plus x plus x is 4x. 1 plus 2 plus 3 is 6, and that equals 90. I'm going to subtract 6 from both sides and get 84. Divide by 4 to get 21. So the first integer is 21. The next is 22. The next is 23. The next is 24. If you were to add those up, you would get 84. I'm sorry, you would get 90. A company sells packages of cookies. Each package should be 15 ounces, but can vary by up to 1.5 ounces. Okay, so this is well, I guess I should keep reading, sorry, before I just start solving. Write and solve an absolute value equation for the cookies that are within an acceptable range. Okay, so we want our cookies to be equal to 15 ounces, but they could be off by 1.5. If you're wondering if that's true or if it works, this is where I would say plug in, or actually solve it, and then plug in your answers to see Because I think that you understand that, okay, a package should be 15 ounces, but every now and then you get one that's maybe 16 and a half ounces. And is the company okay with that? Yes. And then even every now and then you get one that's 13 and a half ounces with that. And are you okay with that? I mean, you're a little like, meh. This one you're happy with, and this one you're like, yeah, score, more cookies. But to the company, you're good. So basically, let's see what this looks like. So our absolute value is by itself. So let's solve it for the positive version. Let's solve it for the negative version. I add 1.5. There's my 16.5. Okay? And now, hang on for a second, because when we add 1.5 over here, we get negative 13.5. And you might think, well, wait a second. That's not, these two aren't the same. But if you were to take this and plug it in here, you'll see something. So I'm gonna do that kind of like slide over here. Oh wait, I can slide over to the edge. The absolute value of negative 13.5 minus 1.5 equals 15. We'll check this out. Absolute value bars. What's negative 13.5 minus 1.5? It's negative 15. So we know that the absolute value of negative 15 is 15, and does 15 equal 15? Yes, it does. So this is one that it might be a little tricky. We didn't maybe do tons and tons of it, and we will hopefully understand it more in the future. I know this is a little kind of off topic for the test, but I told you that this is a parent function. This, actually, that's probably the kid. The parent looks like this. And what we're doing is we're moving left and right. We're moving kind of left and right of center. Okay, so 15 is our center, and that's 1.5 on either side of it. And if you're like, wait, I kind of remember him writing that, but how is that relevant here? How am I supposed to remember that? What we're supposed to think about is if I had the absolute value of 6 or the absolute value of negative 6, that those are both exactly 6 from 0, right? And it's because they didn't equal anything like here. When it equals this, that is when we kind of get a new center. Okay, enough explanation on that. Let's check out the last one. A certain machine operates properly when relative humidity H satisfies the inequality. Solve for H to find the range of values for which the machine operates properly. So really, all of this info up here is just to tell you to find H. So here we go. Going to distribute 3, mainly because I don't find it to be really helpful if I were to divide by 3 right now. I'm going to add 75 to, well, hang on. So this is one where I like to do like just all one gigantic inequality. If you would like to do 2 separate ones, go for it. Adding 75 to both sides. So here, or all sides, I should say. And I get 25 is less than 3h, which is less than 175. I'm going to divide by 3, so I get 25 thirds and 175 thirds. If you want to leave it like that, go for it, because neither of those is truly divisible by 3, but 25, if you were to do that, it's 8.3 repeating. And let's see, I think this is something like that. 6 times 8, nope. 6 times 5. And then there, it's 58.3 repeating. Okay, that is it. That was the practice test. If I went too quickly through some of these, please, don't hesitate to say, hey, what the heck did you do here? But generally speaking, the things that I skipped over were just some of the things like writing out that I'm distributing 3 here, right? And then also like subtract 15 to get 0. And then like subtract 3x to get 3x right here. Okay, so like I said, if you got any questions, let me know. I'll see you later.